Yo, what's up, everyone? Back at it. It definitely feels like a long time since I did a video, um, but the grades are much more settled now, and hopefully you're a lot more settled too. So we're in week 7, and we're almost done with the quarter, and honestly, almost even done with this unit. Um, but we just are going to do another lesson, okay? So we are going to have a quiz this week covering scatter plots because this will actually be the third, I think, or fourth. I should know, but the third or the fourth scatterplot video. So we're gonna have a quiz this week too. But if you're watching, just know that I really appreciate you, and I take a lot of time to come up with my lessons. Um, that's hilarious. I messed up a little bit. And what I wanted to say is that if you're actually watching this video, I really appreciate you because I know a lot of kids don't watch the videos. A lot of kids don't even they just copy everything. But I really think they're wasting their time, honestly. And I spend a lot of time making my lessons and trying to make them accessible and interesting. And I do it all for you, which is like the people who actually care. Okay, so if you care, I really appreciate you because I'm doing it for you, and it's no big deal that it's not everyone, but I know it's at least like 50 people in this class alone. So yeah, the data we're looking at now is Steven Spielberg Oscar-nominated movies, and this data is made up. You could find real data, but I always kind of want specific things to happen in the scatter plot. So this is made up, but close to the truth. Okay, and we're looking at each movie's production cost, so how much it costs for the movie to be made, and also comparing it to the box office, so how much money it earned when people went to go see it. And what that means is that each of these dots represents a movie and how much it costs, the production cost, compared to how much it made at the box office. So remember that there's always an x and a y, two variables, and whenever you're doing a stats problem, you really want to try to get into what the question's asking. And if you do, you're going to be able to kind of understand the word of problems a lot better. So in this case, if you look at a single dot, its x tells you how much it cost, and its y tells you how much it made. So the first question is really easy, but we kind of had to get back into the mode of doing math in this class versus just kind of making graphs and kind of not too much technical work, because A says circle the 2 points you believe are farthest from the line. And that shouldn't be too hard, right? This point is pretty obviously the farthest from the line. And if I'm looking, this point also looks pretty far, right? Everything else looks pretty close, but this on the opposite end looks pretty far as well. Okay, so we have our 2 points, but when we list them, you have to make sure you're using coordinates. Okay, this point is 150 for x, comma, whatever it is for y. Okay, and honestly, I've been becoming more and more advanced in my chart making, so I hope you're proud of me, because it should be really easy to estimate these points. Okay, so I'm going to do that here, but we have 2 points, and we want to list them as coordinates. And we have these 2 points, and the rest of this is going to become pretty technical with this, which is cool, but we're going to kind of figure out what we're doing. What B says is how much did each of them under or overperform. Okay, and let's just talk about this point first. We know that this point is 150 comma 150, and if I'm reading that, what that means is that it cost 150 million. Sorry, let me write that in. All of this is in millions. It cost 150 million, but it only made 150 million too. So not only is that bad because there's no profit, but if we're looking at a scatter plot, let's remember that this line, which I like to call the line of best fit, but we have many names for it, so I'm adding a third now, which is the least squares regression line. This tells us what we predict at every x value. Okay, so we knew that this point was really far away, but what we can also say is that if a movie costs 150, what do we expect to happen? We expect that movie to make $950 million. Not only did it not make profit, but it's expected in this case to make 800 profit. Okay, so hopefully that makes sense to everyone, and I think that's really, really interesting. That's what the line of best fit does. it predicts y values based on x. So when you're first, and you did this intuitively, when you're looking at these points and figuring out how far away they are from the line, you're always finding a vertical distance, okay? And we're going to have a word for that vertical distance, but in this case, let's calculate exactly what that vertical distance was. If we expected 9,950,000, and it actually was 150, this movie underperformed by $800 million. And what we just did, logically, we're going to do now technically with what is called calculating the residual. But I hope you found that really cool. But again, all the residual tells you is the difference between what happens and what we expect to happen. And the way that we're going to say that from now on, a phrase that I want you to be comfortable thinking in your head a lot, is observed minus expected. Okay? So we have this 1 point, 150, 150, and we observed 150. But what did we expect? We expected 950. Now here's where we're going to get a little bit more technical, and I think this is cool. We just estimated that because this graph is pretty accurate, but you should always use the equation for your expected value, okay? And we've actually been doing this since like the first worksheet. Oh, and I pray that this was on the worksheet. I bet a lot of that was not even on the worksheet. Let me just zoom out. Wow. The sun is coming in. It's kind of pretty. Wow. Okay. But this expected value, we can solve it, and we've done it since like the first worksheet, by just putting 150 into the equation. In this case, the x value is also 150, so you plug 150 in here, and if you do that, you'll be satisfied because you get 954.5, or really close to our prediction of 950. Okay, so hopefully that makes sense, that you're going to take your point 150 minus what's expected at the x value 150 to solve your residual. Okay, so in this case that residual is negative 804.5 million. So let's just do it again now for the second point, now that we kind of went through an explanation, so that we can talk about how quick this is done. But if we ever want to calculate the residual, think that that's how far away is this point from the line. And we do that by doing observed minus expected. So at the x value 5, we observed 700. This movie did way better than expected. Expected can be found by putting in 4 into the formula to figure out where it is here. We're trying to find this distance, and we found this point as 700, so this is going to be whatever 5 is if we plug it into the equation. And again, you honestly could have predicted that from just looking on the graph, and it looks like it's 250 and it's 248.5. But if you understand that, then you're in a really good place, okay? Residual is just the distance between the point and the line, but you always have to do observed, or the point, before you do the expected value. Okay, so point before what's expected. And the reason for that is that we actually really care about whether or not this answer comes out positive or negative. That's pretty funny. I think I made like 50 or more videos from this year and last year, and like, I don't know if the sun has ever come in quite at this angle, or I've never done it exactly at 6:02, or like approximately 1 hour before sunset. But I don't think you mind. I think it's pretty cool. Okay, but I keep getting sidetracked. Honestly, I thought this was gonna be a really good lesson. And I think it still can be. Okay, so let me get back in the zone. So this residual ended up positive, and that's really important because this movie overperformed by 450. Okay, so you have to do the point before you do the line, so that if the line is if the point is above the line, it's positive, and if your point is below the line, it's negative. Okay, so that's really important. That's the formula for a residual. And then it's going to ask us to do that one last time. So I'm just going to speed through it, but follow my lead. Okay, so for C, I got negative 18.8 million, and it's this point which is really close to my graph, and the residual is really small in comparison to these other two, right? The other two were much bigger. And now is this kind of a second big point here, and I think it's really interesting. For D, it says, if the point 150, 150 was removed from the scatter plot, what would happen to the correlation? Damn, I had to cover it because I thought it was too distracting. Okay, because looking at the graph is really important. So what E asks us is what's going to happen to the correlation if we remove this point, okay? And first, let's think about what correlation means. And correlation is how accurate our line is. It's like the spread of a scatter plot. If all the points are really close to the line, then we have a really high correlation. And in this case, it's a pretty high correlation, right? If we look, other than these kind of 2 points we've identified, most of it is like really close to this line, right? A lot of them are kind of far away, but not really that far. In general, the line is definitely predictive. But the question is, what happens if we remove a point? And in this case, I want you to think of this point as an outlier. And in this unit, there's no such thing as an outlier formula. You just have to think about points that are far away as outliers, like movies that really did way better or way worse than expected. But if we remove this point, what happens to the rest of my graph? The line would be much better, right? The correlation for the entire thing is going to increase if you take away a point that's far away from it. And we're going to get to this in the next one, but this line would actually change if we took away this point, because it could better represent the other ones with a different line. So outliers hurt the correlation. We don't want that point that's really far away if we want to say the line is accurate. And then all that the next one says, and it's kind of just on the next page, is what's going to happen to correlation if we remove this point. And this is a little trickier, even though the answer is really quick. But if you take away a point that's helping your line, think that the correlation is going to go down, okay? Not by a lot. The line's not going to change, but think that this point is really supporting this line, right? This point is saying that this line is really accurate because it was so close. It had such a small residual. So if you remove a point that's far away, that's going to make your line better. But if you remove a point that's good, think of it as a good point for your line, that's going to hurt correlation. Okay, so the next question has two graphs, and I think this is one of my favorite lessons I've ever done, or like side thoughts. So I really appreciate you for continuing to listen. A says to find all the residuals, but I don't want to do that right now. I want to save time, so I'm just going to skip it. But I am going to circle these 3 points. So let's talk about the data we have, because the most important thing is to get into the mind of the question you're reading. And it's comparing 2018 wins to 2019 wins in 2 soccer leagues. And what that means basically is if a team is good the year before, could that predict how good they're going to be this year? Which seems like really fundamental. And if we look at the scatter plots, you know, it would suggest that the winning teams are always winning no matter what year. So that's my quick analysis getting into the head of this question. And let me circle these 3 points, because they're going to be the big focal points of my thought experiment. Okay. Now this question is really boring because all 3 of these things ask the same thing, but what we're going to talk about is an extension of the last question, and what happens if we remove points from my graph. Okay, so we're going to really zoom in on this first one, And what C asks is what's going to happen to my scatter plot, the correlation, and the equation if this point is removed. So first, here's my suggestion. If you ever have a question like this, put your thumb or your finger over it so that you can see what's happening without that point. Okay? So first, you remove an outlier, think correlation increases. But the second part of this is the new part, and that's what's going to happen to my line of best fit if we remove this point. And what the line of best fit, I'm going to give a deeper explanation for this, but what it calculates is the line that gets closest to every single point. Okay? So if you remove this point, you can change the line to better represent what's left over. Okay? So if it's asking us how the line is going to change, we have to think, what is this point doing to begin with? Right? This point, because it's on the left side of my graph, so it's on one of my sides, it's pushing my line up, right? If this point wasn't here, the line could be lower and better represent these points, okay? So an outlier point, you really just have to kind of think about this and maybe even pause and think about it, because I think it's fascinating. This point is really screwing over these points that are on the same side as it, right? If I look on the other side of my graph, they're actually pretty well represented, right? So what I want you to think is that this point forces my graph upward on the left side, but doesn't affect it as much on the right. So if I were to redraw this, maybe something like that, okay? Now what this means is what is the difference between these two lines. And it might be subtle, but this line has a greater slope, okay? And let me think about how to really make sense of this. But hopefully understand that if we take this point away, we can represent my other points more by changing the line. And the line is going to get a lot lower on the left side because that's where the point was, and be kind of similar on this side. And this line is closer to these points, it's even closer to these points and these points. It's a little farther, but not too much farther from those. Because it was an outlier on the left side, that's going to increase the slope of the line and then also decrease the y-intercept, okay? And this is like a really difficult concept, the hardest I think in the unit. So if you're struggling, this is kind of something to think through, but it's not the end of the world if that's difficult, because we're going to kind of expand upon that with the next one. I really just want you to think that the line pivots, okay? That's kind of the gist of this. If you have that point on the side, and maybe we should just go back to this. If we didn't have this point, this is from the first example, your line's going to pivot upward, okay? It's going to kind of even go even lower here, right? It can actually better represent these points by going lower. That was decently good just by hand, but think that the whole line is pivoting slightly upward. And if you're like, how is that an increased slope? Let me just do a quick thought experiment. Think that if I kept doing that, that line is like becoming vertical. So that slope is definitely increasing, okay? And in the same way, the line is increasing here. So each example kind of is to their own, but that's an example of an outlier on the side. So let me write this and then say it again. So the correlation is going to increase, and then the slope of the line is going to increase, and then the y-intercept in this case also decreases as we pivot. Okay, and let me just really make this clear, like this is hard, and it's not going to be the end of the world if you don't get these things perfect. But to finish this out, and then, you know, for C, it talks about this point. If this point is removed, so imagine we're going to ignore this now, nothing is going to happen to the line, okay? The line wasn't adjusting for this point to begin with. Okay, so if you take away a point that's really close to the line, it's going to hurt the correlation because it was a good guy in that sense, but the line itself isn't going to change because it wasn't like a big factor in the line anyway. So correlation is going to decrease and no change to line. And I would say understanding if there's a change to the line is almost as important as knowing what that change is going to be. But now let's talk about this final one, which I think is really, really interesting. It's asking us what's going to happen if we take away this point. And this is an outlier, right? If we're going to get into the mind of the question, this team really did much better season 2. The first year they had 17 wins, and the second year they had a really monstrous season and won 39 times. Okay, so this was an overperformance. Obviously, the residual would be positive, but now we have to think what would happen if we took this point away. And how this is different than the last one is the location of this outlier. This is an interesting outlier because it's in the middle of my graph, right? This team wasn't a big loser or a big winner in the first season. They were just an average team that really did better in the second season. And let's think what would happen if you remove that point. This point pushes my graph up, right? If this point wasn't here, it wouldn't have to worry about this huge distance. Because again, the line is figuring out a line of best fit where each point is as close to the line as possible. So if this point wasn't there, the line can go down. Okay? But because this point isn't on either side, it's not really going to pivot my line much. It's just going to move the whole line down a little bit. And now if you think, what points here are being the worst represented? We have a lot of points that are below the line. And only really 2 points that are much above. So many of the points are below the line. And that's because my line is only being pushed up by this point. So it would be a little higher than that, but you have to think that this point in the middle of my graph pushes the whole line upwards, which doesn't affect the slope, but is going to make the y-intercept increase. So when you do these questions, look at the answer keys if you're dedicated to further that logic, but that's like a really high level question, and I'm proud of you, so let me write that down. Okay, so that's that. The main purpose of this lesson is to calculate residuals, but we also kind of want to be thinking what's going to happen if we remove outliers from a graph. So this video was a little longer than usual, but I've been pretty easy on you recently, and we kind of got to get back in the swing of things. So yeah, really good work.